Okay, welcome back to the second bonus video. So first thing I'm going to do is pick up where we left off. And I'm going to do a quick file, save as, and make this file B2. We start with B1 and end with B2. Okay, so now we're going to add some insight to this that we can do once we've done these calculations. All right, so the first thing is, let's say I'm looking at a 1,500 square foot house. So my quick estimate for that is, we'll call that house, you'll scroll up just a touch here, house X, or yeah, maybe we'll call it house Z. How about house H? And the square feet is 1,600. 1,500, I meant. How much do I feel I could pay for that house on average? Don't forget, these are averages. And a good point about the averages is the fact that, the average means when we plug in a value like 1,500, which isn't a pretty good, clump area here, whatever that Y value is, which we can estimate, we're going to calculate it on the other tab, that's the average of all the 1,500 square foot houses and close to it. So keep in mind that we're working with averages. We're going to add some spread around that in a minute. Okay, so I can say my house price here, which I'll make in yellow, just to remind me that it's an estimate, is equal to the constant in B2 plus the slope in BC2 times the 1,500 square foot house I'm looking for. So that house should cost me, suppose I should make it the same decimals as above, just about $175,000. And that's not too bad, assuming I got some other cool things with it. But now we can put some deviation around that. Like everything where we're making estimates about an unknown population, and don't forget, this is only, it's not even 39 houses, it's 38 houses. Anytime we're making an estimate, we want to have some error around it. So to get the standard deviation associated with that estimated house price for a 1,500 square foot house, I need to do a couple more calculations to my SSE. First thing I need to do is divide it by n minus 1. I'm not going to get too fancy here, particularly because I'm still having trouble typing. So I'm going to format that here. And keep in mind that we only have 38 houses. So I'm going to say that's equal to that number divided by 38. Because we're just learning here. So then that is the variance. So the next thing I'm going to do is divide that, or raise that to the 0.5 power, which essentially means, little format painter there again, when I raise that value that we just calculated to the 0.5, I'm taking the square root of it. And so, we'll make these bold as well. So this is the variance, and this is the standard deviation, which is better known as the standard error of the estimate. And so often that's S or S period E, or in full, the standard error of the estimate. And so that is an important number. So I'm going to put that, maybe we'll use a different color. I really don't like, we use sort of that amber caution. So now I can calculate, maybe I'll rename this as estimated price, and I can get a lower limit and an upper limit in a very similar fashion as to how we calculated a confidence interval. So if you recall, we took our point estimate, which is 175,800, and we're going to first subtract out 2 times the standard error of the estimate, and then we're going to do the same thing, except we're going to add 2 times the standard error of the estimate, and we'll add a decimal here. And so that means, since we added plus or minus 2, we're going to be looking for something in the 95%. So my tagline here is, I am 95% confident that a 1,500 square foot house should sell between 108.8 thousand and 242.7 thousand. And so if I look for, do I have any 15? There's one that's close. 35, here's one that's really close. That one sold for 168. That's well inside the range. Here's one, 175. That's well inside the range. So you can kind of go back and look at the data to see how well that worked. Now, the flip side of this is, one might say, hey, that's an extremely wide range. Is that really helpful? So now let's marry a couple of thoughts together. We go back here and look at the R-squared value. Nicely provided. 75% of the variation of the square footage can predict the price of the house, which also means that there's 25% that's unexplained. And so that might be a reason why our range is so wide. Is this 33,500 or so standard deviation too high? Probably. What can we do to lower it? So what can we do? 2 things in general. We can get a bigger sample size, which is probably possible, or perhaps we can look at other factors that allow us to reduce the error. Again, reducing the squared error, reducing the eventual standard deviation, or more appropriately, standard error of the estimate. Again, just to reinforce, standard error of the estimate is the standard deviation associated with predicted values of y, such as our estimated price for a 1,500 square foot house. And we now have a handy tool that we can change that number at will. Maybe we want to look at a 2,500 square foot house. It works very nicely now that we've got everything all set up. So here, let's look at a couple of other things. Particularly, to wrap up this video, house number 37 and 38. And sometimes the data works out nicely. So that allowed me to keep it on the screen while I'm talking about it. For house number 37, it was a 1,600 square foot house. The predicted value was 182,000. We were only off by about 5,000. That's fantastic. Even the square deviation is ridiculously low. Now compare that to house number 38. And if you're really getting this, you'll catch what I'm going to do next. House number 38 was that small house with a big price. So what's going on here? The predicted value was almost half of the actual price based on a popular website. And the squared error was 22,000. That squared error contributed to over half of the sum of the squared errors. Well, there's another thing that we can do is perhaps go back, if we had the address, and look more closely at that house. Is this a particularly unusual house? An outlier in the sense that only about 1 in 400 or 500 houses in the entire area that we're interested in would kind of fit that pattern. Maybe it has an extravagant pool. Maybe it has a big property because they do a little farming or something. That value of house number 38, we might want to consider removing. So if we look at that and compare it to there's a 7,000, that's the next high. Look at all those other values in terms of the squared error. There's only one other one that even comes, anywhere near in the same neighborhood. And perhaps in the next video, we can take a look at removing it and see what happens. The other thing we're going to do in the next video to additionally try and explain better what impacts the price of a house is add in another variable like the acreage. See you in the next video.